right now, the artificial intelligence models that are, drafting your emails or summarizing your meetings or generating code.
They're burning incredible amounts of energy.
Yeah, literally enough electricity to power small sovereign nations. It's wild. And a massive percentage of that energy isn't even doing math.
No, it's not.
It's just being used to power giant industrial fans, like these massive liquid cooling systems, just to keep traditional silicon servers from melting into slag.
Right, because of the heat. It's a fundamental physical limitation.
Exactly. So for you listening, I mean, think of it like this. We are currently building 1 million massive, ridiculously powerful gas-guzzling engines. And we're scrapping them to 1 million different cars and racing them all to the exact same red light.
That's a very apt analogy, actually.
Right. Like, there is so much power being burned, but collectively, we aren't actually getting anywhere.
We're trapped in a bottleneck.
Yeah. But so what if we completely abandon electricity? What if we built computers out of pure light?
Which sounds like science fiction, but it's very real.
It really does. And what if we use that hardware to construct a shared global intelligence network, like something closer to the International Space Station than, a corporate product?
Well, it's a radical proposition. I mean, we are looking at a system designed from the ground up to force global cooperation.
Yeah.
And to do it through the sheer physics of its hardware.
Which is exactly what we are unpacking today on this deep dive. We have this highly ambitious, deeply provocative framework proposed by Professor Dr. Guy Lakeman.
Right, the architecture of global superintelligence and photonic integration.
That's the one. And alongside his written arguments, we are meticulously dissecting this conceptual diagram he provided. He calls it the University of Superintelligence.
It's a fascinating blueprint.
It really is.
Yeah.
So we're going to start with his diagnosis of where AI is failing us today, dive deep into the microscopic physics of computing natively with light.
Which is mind-blowing.
It totally is. And then we'll trace the pathways of his proposed global AI architecture. So what's your take on his overall approach here?
Well, Lakeman's work operates on two distinct levels.
Okay.
On one hand, it is a highly technical blueprint for the next generation of computing hardware, like detailing this massive shift to photonic integrated circuits. But it is equally a philosophical manifesto on how humanity ought to govern itself. I mean, he argues that our current trajectory is not just inefficient, but fundamentally destructive.
Yeah, he pulls no punches.
Yeah.
But just to be clear for you listening, we're going to impartially dissect both the engineering he proposes and the structural critiques he levels against the current ecosystem.
Exactly. We aren't endorsing the politics. We just want to understand the mechanics of his blueprint.
Right. How it works and why he believes it's the only viable path forward for human evolution in the face of superintelligence.
So we should probably start with his diagnosis.
Yeah, let's start there. Because to understand this massively complex University of Superintelligence he's proposing for 2026 and beyond.
You have to understand what he thinks is broken right now.
Exactly. And interestingly, he doesn't think the problem is a lack of capability.
No, not at all.
He explicitly cites current cyber intelligence systems. He specifically calls out developments from Google DeepMind and various Chinese state-backed systems.
Right. He notes they're already demonstrating competence that surpasses human intelligence in a lot of specific domains.
Right. So the intelligence itself is a solved problem in Lakeman's eyes.
Yes. The failure, according to him, lies entirely in deployment.
Okay.
He observes that these incredibly capable systems are trapped in what he calls a multiple energy wasting competition.
That's the phrase he uses, yeah.
And he views the current ecosystem as being driven by, quote, self-appointed elites engaged in a wasteful political competition.
Which is pretty heavy language for a computer science paper.
It is. But looking at this strictly from a systems analysis perspective, he is pointing to the massive commercialization of AI. The primary structural goal right now is zero-sum dominance. It's a race to build a slightly better model to capture market share rather than, pooling resources for collective advancement.
He uses another phrase that really stuck with me. He says this corporate militarized competition serves to fog the internet of users.
Fogging, yes.
Yeah. And if you've ever felt like your search results are getting worse instead of better, or that you're just drowning in AI-generated noise,
this concept explains exactly why.
Structurally, right. Fogging implies the introduction of deliberate confusion and redundancy instead of a clear, streamlined network where you ask a question and get like the most accurate, universally agreed upon answer.
A fog internet is a zero-sum game of engagement.
Exactly. You have multiple massive AI models generating overlapping, sometimes contradictory, and highly resource-intensive responses.
It is comparable to a highly polluted river of information. I mean, instead of a single clean reservoir of knowledge, you have dozens of massive factories.
These corporate AI models.
Right. And they're all dumping their process data upstream simultaneously.
To churn it out.
So the resulting fog is the chaotic byproduct of all these separate, siloed architectures, just churning out data without any unified direction or cooperative protocol.
And Lakeman doesn't just see this as annoying for the end user. He asserts that current AI evolution is being hijacked by brinkmanship and hegemony.
Yes. He views this as a literal biological and evolutionary failure.
Wow.
In his framework, a highly advanced intelligence should naturally strive to support the survival and evolution of the species that created it.
Which makes sense.
But because of this fractured competition, staggering amounts of global capital, computational power, and literal electrical energy are being misallocated.
He actually draws a direct causal line between this misallocation of funds and real-world misery.
He is quite blunt about it. I mean, there's a specific quote in the text.
Oh, I have it right here. He says, "Say goodbye to greedy bastards trying to sell crap and strive towards quality of life."
Yes, that's the one.
Wait, calling tech CEOs greedy bastards trying to sell crap sounds way more like a utopian rant on a message board than actual computer science or architectural theory.
I know, it really does.
Is there real hard engineering math backing up this anger, or is he just venting about capitalism?
Well, the rhetoric is intense, obviously. But when you strip away the emotion, you actually find a very literal, pragmatic critique of the hardware running current large language models, or LLMs.
Okay, so it goes back to the hardware.
Yes. The greed and waste he describes are literal descriptions of thermal dynamics and computational inefficiency.
Interesting.
To build and run the massive monolithic LLMs we see today, you need warehouse-scale deployments of traditional silicon graphics processing units, GPUs.
Right.
And these GPUs consume gigawatts of electricity. But crucially, as you mentioned earlier, a massive portion of that electricity isn't even performing calculations.
They're just cooling it down.
Exactly. It's just being used to keep the system from overheating because pushing electrons through silicon generates enormous amounts of heat.
Which brings us to the physical foundation of his entire proposal. Like, if the problem is that massive, single-entity LLMs are inherently energy wasting because of the physical hardware they run on.
How do we fix it?
Right. And Lakeman's answer is that we have to completely abandon electrons.
We have to start computing with light.
Which is just the coolest concept. So this is the shift from traditional silicon semiconductors to what are called photonic integrated circuits, or PICs.
Correct. And to understand why this is necessary, we have to look at the foundational design flaw in almost all traditional computers today.
The von Neumann architecture.
Yes, the von Neumann bottleneck.
I can actually break this down, because it's conceptually pretty simple once you visualize it.
Go for it.
So, in standard computing design, the computation cores, the parts that actually do the math, are physically separated from the memory storage, which holds the data.
Right.
It's like having a world-class chef, which is your processor, working in a kitchen that has absolutely no pantry.
That's a great way to think about it.
Right, so for every single ingredient, a pinch of salt, a single onion, the chef has to stop cooking, walk out of the kitchen, go down the street to the grocery store, buy the ingredient, walk all the way back, and then resume cooking.
And in the physical world of a computer chip, that walking back and forth is accomplished by pushing electrons over tiny copper wires.
Right.
Every time an electron moves through a conductor, it encounters physical resistance from the atoms in the material.
And friction causes heat.
Exactly. That resistance generates heat. Furthermore, moving that data takes a microscopic but highly significant amount of time.
So the chef is just standing there.
Yes. The incredibly fast processor is constantly sitting idle, waiting for the data to arrive from the memory, while simultaneously generating massive amounts of heat.
Which you then have to spend additional energy to cool down.
Precisely. And when you scale that up to the massive parallel mathematical operations required by an artificial intelligence model with trillions of parameters,
The inefficiency becomes catastrophic.
it does.
So, enter the photonic revolution. The source material heavily highlights a specific technological breakthrough, right? The QANT photonic chip.
Yes, developed by a German deep tech company.
And they aren't using traditional silicon. They're using a material called thin film lithium niobate, TFLN.
The physics of how this changes the computational landscape are extraordinary.
I bet.
A photonic chip natively computes using light, specifically photons, instead of electricity.
So no electrons at all.
Right. Instead of sending electrons down a physical wire, the QANT chip encodes data into laser beams.
Lasers.
And these lasers are directed through microscopic waveguides etched into the thin film lithium niobate.
But why lithium niobate? Like, what makes it better than silicon for light?
That's the key. Lithium niobate possesses unique electro-optic properties.
Okay, what does that mean in practice?
It means when you apply a tiny electrical voltage to it, it actually changes its refractive index.
Oh, wow.
So you can actively bend, split, and manipulate the laser beams passing through it with incredible precision.
That's wild.
And as these beams of light intersect within the chip, the system utilizes optical interference patterns to actually solve the complex linear and nonlinear mathematical operations required by AI neural networks.
Wait, so the light interfering with itself is doing the math?
Exactly.
So going back to my chef analogy, instead of the chef walking to the grocery store, a photonic chip is like having a frictionless, instantaneous conveyor belt made of pure light. And it delivers the fully prepped ingredients the exact microsecond they are needed.
Yes. And because photons are fundamentally different particles than electrons, the physical rules change entirely.
How so?
Well, electrons are fermions, they have mass, and they cannot occupy the same quantum state.
Right, they bump into things.
Exactly. When you push them through a wire, they bump into things and create friction. But photons are bosons.
No mass.
Right. They have no mass. You can cross two laser beams directly through each other, and they will not short out or interfere with each other in the way electrical currents would.
Which is why you see laser light shows and the beams just pass right through one another.
Exactly. And this allows for massive, unparalleled parallel processing within the chip.
The performance stats provided in the text for this QANT native processing unit are just staggering.
They are.
They're promising up to 30 times lower energy consumption compared to traditional silicon GPUs, and up to 50 times faster performance for AI workloads.
But the most critical statistic for Lakeman's thesis, however, is the thermal output.
Right.
0 on chip heat.
0.
Because the light isn't creating electrical resistance, the chip produces virtually no heat during computation.
That is insane.
It instantly eliminates the need for massive, energy-draining cooling infrastructure in data centers.
Yeah, so no more giant fans.
Right, and the computation density is equally impressive. The TAC notes that a single optical element in a QANT chip can perform operations that would typically require 1,200 traditional transistors on a silicon chip.
One optical element replacing 1,200 transistors. That is a completely different scale of engineering.
It really is.
But practically speaking, how does this roll out? I mean, are we expecting data centers to rip out every silicon server on Earth tomorrow and replace them with lasers?
No. The transition doesn't require destroying the current infrastructure.
Oh, right.
The QANT system is designed as a highly specialized hybrid accelerator. The hardware is housed in a server chassis that plugs seamlessly into existing infrastructure.
Like using standard ports.
Yeah, standard PCIe interfaces, the exact same physical slots you use to plug a graphics card into a motherboard today.
Oh, that makes it so much easier.
And it routes data back to conventional digital memory when necessary. Crucially, it integrates directly with the software environments AI developers are already using, like PyTorch and TensorFlow.
So a developer doesn't need to learn, like, a whole new programming language to write code for light. The hardware just handles the math invisibly in the background.
Precisely. The sources mention it is already being deployed in high-performance computing environments.
Right, like the Leibniz Supercomputing Center in Germany.
Yes. It is an evolutionary leap that integrates with current architecture, just offloading the heaviest computational burdens to photons.
Okay, so we know the physics work. We know it solves the energy crisis and the von Neumann speed bottleneck. But if Lakeman's vision for a global university of superintelligence is ever going to exist, someone has to physically build these optical chips on a massive global scale.
And this is where the source material pivots.
Right, it pivots from German deep tech to geopolitical supply chains, which is a fascinating turn.
The text states plainly, quote, NVIDIA already has the interconnect spine philosophy and high-speed interfaces, but the photonics edge is in China manufacturing.
Wow.
While the fundamental research might be distributed globally, the sources point very specifically to China as the engine for mass manufacturing and strategic advancement in photonic integrated circuits.
And there is a deep strategic reason for this, right? It has to do with how computer chips are physically made today.
It does.
Right now, the United States and its allies have strict export controls on advanced semiconductor manufacturing equipment.
Right, specifically machines made by the Dutch company ASML.
Yeah, ASML, which use extreme ultraviolet lithography, or EUV. You need these massive complex machines to print the microscopic 3-nanometer and 5-nanometer silicon transistors used in the most advanced AI chips today.
And China has been cut off from buying these machines.
Exactly.
Which is where photonics provides a brilliant workaround for supply chain sovereignty.
How so?
Well, the sources mention that China is intentionally creating a closed-loop system for photonic chip fabrication.
Okay.
Because light waves are physically larger than electrons, the components on a photonic chip, the waveguides and modulators, they don't need to be printed at 3 nanometers.
Okay.
They can be manufactured using older, mature 90 nanometer or 130 nanometer fabrication processes.
Wait, which means they can use the older lithography machines they already possess?
Exactly. Entirely bypassing the Western sanctions on the cutting-edge ASML equipment.
That is wild. So they can build chips that perform 50 times faster than the best silicon GPUs using older, cheaper manufacturing tools.
Yes. It completely upends the geopolitical chessboard of computing power.
That is a massive shift.
And by leveraging materials like lithium tantalate, they are dramatically lowering the cost and increasing the scale of production.
I saw that in the notes. The Shanghai Institute of Microsystem and Information Technology, or CIMIT.
Right, CIMIT.
They've demonstrated mass production techniques using lithium tantalate that specifically bypass these restricted equipment choke points.
And the scale is already massive.
Yeah.
The CHEP hub in Wuxi is currently operating a pilot line, producing 12,000 6-inch thin film lithium niobate photonic wafers annually.
12,000 wafers.
Yes. And you have universities like Tsinghua and Shanghai Jiatong developing the LightGen AI accelerator.
Right. Explicitly designed to drastically reduce power consumption while maintaining processing speeds.
The text also highlights collaborative efforts between entities like ChipX and Turing Quantum.
They're working on.
They're creating scalable optical quantum chips designed to fit into standard data center racks. And they claim these specific architectures can accelerate certain highly complex AI workloads up to 1,000 times faster than digital processors.
1,000 times faster. I can barely wrap my head around that. But to physically connect all these light-based chips together, you need an entirely new type of physical infrastructure, don't you?
You do. The sources mention hardware support companies like Robotechnic, which provides high-speed assembly for co-packaged optics and optical circuit switches. Which
leads to a really fascinating quote in the text from Geoffrey Hinton.
Ah, yes. One of the foundational figures of modern AI.
Exactly. Lakeman notes this quote. Hinton says plumbers will keep their jobs, except they will be plumbing light pipes.
It's a great visual. Imagine walking into a traditional data center today.
Okay.
You are assaulted by the noise of massive industrial fans. You feel the physical heat radiating from the racks of servers.
Right, it's loud and hot.
And running behind all those servers are thick, heavy bundles of copper cables routing electrical signals.
Right. Now, compare that to a photonic data center.
It would be virtually silent.
Silent, because there are no fans, because there's no excess heat to dissipate.
Exactly. And instead of thick copper wire, the data flows through intricate networks of fiber optics.
Like threads of glass or plastic thinner than a human hair.
Carrying multiplexed lasers of different colors. The plumbing Hinton is referring to is the delicate, ultra-precise physical alignment of these optical fibers into the server inputs.
So the data isn't a pulse of electricity anymore.
No, it is a constant physical stream of light zipping through transparent pipes.
That is just incredible.
Hardware is destiny in Lakeman's framework. You cannot build a globally beneficial, frictionless superintelligence on restricted, energy-draining, heat-generating silicon.
It's just a dead end to him.
Right. Photonics is the required physical substrate. Without this underlying light-based hardware, whether utilizing lithium niobate from Germany or mass-produced lithium tantalate from China,
his whole vision falls apart.
Yes. Lakeman's vision of a cooperative, energy-abundant future remains physically impossible without it.
Okay, so let's assume we have the ultimate energy-efficient photonic hardware fully deployed.
Okay.
How do we structure the software running on it? Because if the primary goal is to avoid those giant energy-wasting monolithic LLMs that are currently fogging the internet,
yeah,
what is the architectural alternative?
Lakeman proposes abandoning the super large LLM entirely.
Entirely.
Yes. Instead, he introduces the architecture of the LCM, the large concept model.
The large concept model. Okay, break that down for us.
The defining characteristic of the large concept model is that it is not a single giant neural network attempting to encode all human knowledge simultaneously.
Okay, so it's not trying to know everything all at once.
Exactly. It is composed of many highly dedicated specialized LLMs, which Lakeman refers to as silos.
Silos. I think the best way to visualize the energy efficiency of this siloed approach is to imagine lighting a massive house.
I like this analogy.
A traditional monolithic LLM is like having a sprawling 100-room mansion, but they only installed one master light switch for the whole place.
Right.
So if you want to sit down and read a book in the study, you have to flip that master switch, which turns on every single light in the entire mansion.
Which is a massive waste of electricity.
Exactly. The attic, the basement, the kitchen, the guest rooms, they all light up, drawing massive amounts of power, just so you can read in one single room.
That perfectly captures the computational waste. In a traditional super large LLM, if you ask a highly specific question about, say, 14th century agricultural practices,
the system must activate vast, generalized neural pathways to process that query.
Exactly. It's expending computational energy across the entire network to weigh the relevance of entirely unrelated concepts.
So it's spinning up its knowledge of quantum physics just to answer a question about farming.
Precisely. But the large concept model, on the other hand, puts a light switch in every room. If you ask about agriculture, it only fires up the highly specialized, dedicated history or agriculture silo.
And the rest of the network.
The rest of the network remains entirely dormant, drawing zero power.
That makes so much sense.
It mirrors how human society manages expertise. I mean, we do not rely on a single individual to be the world's foremost expert in brain surgery, constitutional law, and quantum mechanics simultaneously.
Right, that would be impossible. We rely on deep specialists.
Exactly. Deep specialists who consult with one another when interdisciplinary problems arise. The LCM applies this exact logic to artificial superintelligence.
And there's also a massive practical advantage to this when it comes to maintaining the system, isn't there?
Oh, absolutely. Lakeman explicitly notes, quote, several of these systems are required globally to support servicing, maintenance, and upgrade paths.
So the modularity is crucial for continuous operation.
Very much so. If you have a single monolithic LLM and you need to update its understanding of a newly passed global climate treaty, you risk destabilizing the entire model's underlying weights.
Because everything is connected to everything else.
Right, and fixing that often requires massive, costly retraining of the whole system.
But with an LCM?
With an LCM, you can isolate the specific law or ecology silo, take it offline, inject the new data, run rigorous diagnostics, and bring it back online without ever interrupting the broader global AI system.
It is infinitely more robust and resilient.
It is.
So we have the photonic hardware and we have the siloed software architecture.
Right.
Now we need to understand how these silos actually communicate. Like, how does a user interact with this vast network of specialists?
Let's trace the flow of information through the visual diagram Lakeman provided.
Right. The University of Superintelligence.
Yes. The diagram is structured almost organically, heavily resembling the complex neural pathways of a biological brain.
If we start at the very bottom of the image, we see a wide, net-like structure labeled the Internet of users.
And note the spelling. He spells it internet.
Right. Perhaps implying a deeper, more intrinsically connected internet.
Exactly. This represents all of humanity logging in.
And that base layer funnels upward into a single node labeled AGI, Artificial General Intelligence.
The AGI node acts as the initial translator between the raw, unstructured queries of humanity and the highly structured system above it.
Okay. And from the AGI, the pathway moves up into an I/O access node,
which handles the intake and routing of the data.
Got it. Now, directly above that access node is the absolute heart of the system. He calls it the corpus callosum context disperser.
A very specific biological term.
Yeah. In human biology, the corpus callosum is the thick band of nerve fibers that connects the left and right hemispheres of the brain.
Right, allowing them to share information and coordinate complex thoughts.
So Lakeman's use of anatomical terminology is very deliberate here.
It is. In his architecture, the corpus callosum context disperser is the ultimate triage center.
Okay, how does it work?
When a query passes through from a user, this disperser analyzes the deep context of the problem and determines exactly which specialized silos need to be activated to solve it.
So it breaks a complex query into its conceptual component.
Exactly, and disperses them to the relevant domains of knowledge.
And those domains are visually represented as thick branches extending outward from the center. He labels them cores.
Right.
We see the humanity core, the history data core, the STEM core, the PPE core standing for philosophy, politics, and economics, and the Gov core.
The way he categorizes knowledge within these cores is fascinating.
It really is. For example, in the humanity core, he groups literat for literature, arts, and specifically fantasy together.
Mm-hmm.
Why is fantasy its own dedicated superintelligence silo, rather than being grouped into history or anthropology?
Because understanding human imagination is a distinct, vital form of intelligence.
Oh, wow.
The capacity to conceptualize the unreal, to create mythology, and to dream that is fundamental to human nature.
Yeah.
It requires an entirely different type of reasoning than analyzing the empirical data found in the anthro or archaeo silos within the history data core.
Yeah. So Lakeman is structuring the AI to recognize human creativity not as an anomaly, but as a core pillar of knowledge required to truly understand us.
Exactly.
That reframing of knowledge is even more extreme when you look at the Gov core.
Ah, yes. The text is incredibly explicit here.
Lakeman writes, the government silo should be global ecology is infrastructure. Infrastructure is climate.
This is perhaps the most radical ideological mechanism embedded in the entire architecture.
Really? How so?
Well, within the Gov core on the diagram, we see three specific silos. For medicine, law, and ecology.
So he is literally redefining what government is.
Yes. Transforming it from a political institution into an engineering and biological mandate.
That is profound.
He is arguing that traditional political borders, nationalistic ambitions, and ideological squabbles are functionally obsolete in the face of planetary survival.
Because if the planet dies, nothing else matters.
Exactly. By explicitly equating global ecology with infrastructure and climate within the government core, he asserts that human laws and medical practices must be strictly governed by ecological realities.
So the physical health of the planet is the foundational infrastructure upon which every other human endeavor relies.
Right. Therefore, the superintelligence managing global governance must be programmed to prioritize these interconnected biological systems above all political concerns.
It is an engineering solution to political gridlock.
That's a good way to put it.
You simply program the core mandate of governance to be the continuation of the ecological infrastructure.
Yeah, exactly.
Now, if we look at the very top of the diagram, above all these sprawling branches, there is a distinct cluster labeled High Energy Efficient Superintelligence Cluster.
Right.
It mentions a silo barrier I/O via CCD and features subagents labeled PCB, SM, and TE.
Mm-hmm.
Is this top cluster the ultimate controller? Is it the boss giving orders to the silos below?
It functions more as the ultimate synthesizer rather than a hierarchical dictator.
Synthesizer, okay.
Notice that it is flanked by photonic inference engines and a dedicated superintel agent silo.
Right.
If the AGI at the bottom is a translator and the cores in the middle are the specialized knowledge databases.
This top cluster represents the higher order reasoning engine where novel thought occurs.
Exactly. So if humanity presents a problem that requires historical analysis, complex economic modeling, and rapid ecological infrastructure planning.
The corpus callosum gathers all the necessary data from those disparate silos.
Right. But it is this top cluster computing natively with those energy-efficient photonic chips that fuses those pieces of information together into a cohesive, completely novel solution.
It is the engine of discovery.
Precisely.
Which perfectly sets up the final question of this deep dive. What is the ultimate point of this intricate, perfectly categorized, photonic-powered architecture?
According to Lakeman, the goal is to fundamentally alter how humanity interacts with advanced intelligence on a geopolitical scale.
The sources draw a direct, explicit comparison between this proposed model and facilities like CERN.
Right, the European Organization for Nuclear Research.
And the ISS, the International Space Station. Lakeman envisions this entire architecture supporting a dedicated collective of zoned research.
Which is a very specific type of structure.
Right. But those analogies do a lot of heavy lifting for his argument. Like, why compare a computer network to CERN or the IS?
Because CERN and the ISS represent massive, incredibly expensive, highly complex scientific endeavors that no single nation, let alone a single private corporation, could or should own exclusively.
Right. The Large Hadron Collider at CERN probes the fundamental physics of our universe.
And the ISS conducts vital research in microgravity.
Right.
These facilities exist for the betterment of human knowledge as a collective whole. We routinely see scientists from countries that are fierce political adversaries on Earth working side by side on the ISS.
So Lakeman is forcefully arguing that artificial general intelligence and superintelligence are simply too powerful and too vital to our survival to be treated as private corporate assets or nationalistic weapons.
Exactly. They must be structured and governed as global public utilities.
The text actually states that the system is designed to serve the whole of global society as a safer approach for human evolution.
Right.
We have to impartially reflect on his central thesis here. He is arguing that by removing the profit motive of building killing machines and ending these competitive corporate skirmishes,
this collective structure literally frees up massive amounts of global energy and capital.
And that newly freed capital can then be reallocated toward progress and efficiency and fundamentally improving quality of life.
It demands a profound shift in our current incentive structures. Today, the economic incentive is to build a slightly faster AI to outtrade a competitor on the stock market.
Or to develop superior autonomous targeting systems for the military.
Exactly. Lakeman is proposing an architecture where the system itself is structurally insulated from those motives by its very design and governance.
It reminds me of the early fragmented days of the internet.
Oh, how so?
Well, there was this Wild West gold rush where everyone was trying to build their own proprietary closed-off networks. You had America Online, Prodigy, CompuServe.
You're all walled gardens competing for dominance.
Exactly.
Yeah.
But eventually, the open protocols of the World Wide Web won out because a unified shared network was exponentially more valuable to everyone.
That's a great historical parallel.
Lakeman is essentially proposing that we skip the Wild West phase of AI.
The phase where we are currently burning through massive amounts of energy and capital in a zero-sum game.
Right. And instantly leap forward to building the United Nations of computing.
And when you view the entire framework holistically, you see how meticulously his argument connects the microscopic to the macroscopic.
It really does.
You cannot achieve this CERN-like global AI if you are computationally constrained by the energy crisis inherent to traditional silicon GPUs.
Which means you must adopt the photonic hardware breakthroughs happening in Germany and China.
Right. But having blazingly fast light chips isn't enough. If you run a single monolithic LLM on them, you still create data redundancy and fog the internet.
Therefore, you must solve the software logic crisis by implementing the large concept model.
Utilizing the corpus callosum to route queries to specialized silos.
The hardware physics, the software architecture, and the global political philosophy are inextricably linked in Lakeman's blueprint.
They absolutely are.
We have covered an immense amount of ground today. We started with Lakeman's visceral rejection of the current AI status quo, the energy waste, the political brinkmanship, the sheer inefficiency of competing monolithic models. We zoomed all the way down into the microscopic physics of how lasers traveling through thin-film lithium niobate can compute complex math at 50 times the speed of silicon with zero heat.
Which is still hard to fathom.
It really is. We explored how materials like lithium tantalate are completely rewriting global semiconductor supply chains.
Bypassing existing choke points.
Exactly. And finally, we zoomed all the way back out, tracing the neural pathways of his large concept model, mapping a university of superintelligence designed to function as an interconnected global resource for human evolution.
It is a comprehensive roadmap that challenges almost every foundational assumption of the current technology industry.
It really does. If you take away anything from this deep dive, we hope it's a new lens through which to view the next decade of AI development.
We are rapidly moving beyond the software buzzwords of today's LLMs.
And stepping into a realm where deep hardware physics and global architectural decisions will dictate the future. But before we go, we want to leave you with one final provocative thought.
Yes. If you recall our walkthrough of Lakeman's diagram, there's a fascinating unaddressed question hidden right in its structural flow.
Okay, what is it?
Look closely at the very bottom of the University of Superintelligence. The entire internet of users, which represents you, me, and all of humanity,
Right.
It connects to this vast, beautiful pool of categorized knowledge through a single, distinct bottleneck. A bottleneck.
And that bottleneck is labeled AGI. The artificial general intelligence sits directly between humanity and the I/O access node.
Oh. It is the sole gateway to the entire system.
Exactly. So the thought we want you to mull over is this. If the AGI is the sole translator, the single gatekeeper standing between us and the entirety of this global superintelligence, are we actually the ones utilizing the university? Or is the AGI carefully managing what humanity is allowed to learn?
Wow. A truly chilling and fascinating question to ponder. Thank you so much for joining us on this deep dive. We'll see you next time.